Hello everybody and welcome to a tutorial about Freecad CfdOF tutorial 1 in English. Introduction. The topics we will talk about are the capabilities and the features. We will talk about how to install and how to set up a simulation. Capabilities and features. Freecad CfdOF is a workbench for Freecad. It must be installed separately. Organization. Freecad CfdOF is a preprocessor for meshing and building up the simulation. OpenFOAM is the solver and Paraview is the postprocessor. We will talk about the features. Possible simulations are two-dimensional and three-dimensional, steady and transient, one phase and two phases, laminar and turbulence, incompressible fluid and compressible fluid. The communication from CfdOF to OpenFOAM runs via text files. These text files can be adapted. A lot of features of OpenFOAM are covered by CfdOF. For features not covered by CfdOF, the text file for OpenFOAM must be adapted. Now we will talk how to install. This is how you find the Freecad installation, and here you have the different workbenches. You see that CfdOF is already installed, but in case it's not installed, you go to the tools and go to the add-on manager, and here you can select CfdOF and tell CfdOF to be installed. But this is not all. In the next step you also have to install additional programs. Here you go to edit and you go to the setup, and here you find the additional program for CfdOF. You see that is now all installed, and here you have to install OpenFOAM. That's very easy, and Paraview also installing is also very easy. Just go to install. And what's a bit more complicated is installing of the CF Mesh and the installation of the Hyzer program. The CF Mesh is a mesher, and Hyzer is a program for simulation of supersonic fluid. So I will show you when you install CF Mesh and you install Hyzer, you get an output. The output looks like this. You get a log file, and then you see completed, and then Hyzer is downloaded, it's extracted, and then there is a building. So, and there's please wait, and if there's please wait, you have to wait. You have to wait a lot, but after a while the install is completed, and you should wait until the installation is completed. It can last very long, and I would also recommend to you, here you find two different log files, so the log files for CF Mesh and the log files for Hyzer. You can take a direct look into them. Here is a log file for CF Mesh. You see that there are many things that look like an error, could not open file and so on, but in truth this has nothing, this doesn't mean anything. I've made this installation and everything fine, everything works. You also see some error occurred. That doesn't mean anything. Just wait until the installation is complete. You find this log file also for the Hyzer algorithm for the HISA simulation, and this is a log file. Let's take a look on it. You find also could not open doesn't mean anything, just ignore. Sometimes really heavy errors occur and then you must do something, but yes, normally most errors can be just ignored. So this is the installation, and after you have completed, your system is ready to run. So we can close, and we can now start a simulation. In the next step, we will build up a simulation. First, we have to build up the model. We start with new. So that means that we are building up a new model. The model you can build up with a part design or the part workbench. In this case, we will use the part design workbench. We start with a sketch in the XY plane, and we build up the model with a polyline. Okay, we go up, then we go to the right, go down, go to the middle line, go to the center point, and go to the first point and close. Okay, so we have to remove some constraints, and now we have the shape. In the next step, we have to apply some measurements. This one will be 20 millimeters. This one will be 40 millimeters. This distance will be 50 millimeters. And this distance will be 100 millimeters. And now our model is complete. We can close and we can pad it up. We will pad it up with 20 millimeters. And now our model is complete. We can take a look. Okay. So here we have our model, and then we can start to set up the simulation. For the simulation, we go to the CFD-OF workbench. And first what we have to do is install a container. This one is a analyst container, and this contains all analyst data. Okay. In the next step, we have to define the boundary conditions. First, we need an inlet. The inlet is given with a boundary as a boundary condition. We say this is an inlet, and we want to have a uniform velocity in the x direction with 20 meter per second. Then we can click OK. If we have an inlet, of course, we need an outlet. We define it on the back side. This is our outlet. And this is also inside the constraints. We say this is our outlet. And as a subtype, we have static pressure. Okay. The next constraint is a so-called symmetry constraint. The next constraint is the symmetry constraint. We choose this. So we say we want to have a constraint, and then we can say it is a symmetry constraint. We click on OK, and it's applied. You can see here our constraints, inlet, outlet, and the symmetry constraint. Then we need the walls. So we click here, say this is our wall, and we say that the speed on the walls is 0, so no slip. We also define this for the opposite side. We say this is our wall and this is the wall, and we can say add, and now we need also we can say this is a wall 2. Okay. Now our constraints are given. And then we can start to mesh the model. Meshing, you click on the pad, so you click on the model, and then you go to the mesh symbol, means that you can create a mesh. You click on it, and here you opens a dialog where you can edit the mesh property. CFDOF has 3 different kind of meshers. One is a CF mesh, the other is a snappy hex mesh, and the last is the G mesh. I personally prefer the G mesh, but CF mesh is also a good mesher. As a base element size, we want to have 5 millimeters. So if you want to mesh this part, first you have to write the mesh case. So now it's written, everything you see here, the mesh case is written. You can take a look on the ASCII files. If necessary, probably you can edit, but in this case, not necessary. And then you can start to run the measure. This will last about 40 seconds, and see you in 40 seconds. So the meshing is completed. You can take a look on the mesh. You can click on Paraview to see it in an external program, or you can load the surface mesh. We load this, and as I said, this is a very rough mesh. Normally for CFD you need a much finer mesh, but this is only a demonstration, so this mesh size is very good for performance, so this is why I chose it. So meshing is complete, you can close, and you can see that you have here the properties of the mesh, you have the mesh, and now there are some things missing. You can go to the physics model and say what kind of physics model you have. We want to have a steady simulation. It is a single phase. The fluid is incompressible, but we want to have a look on the viscosity of the fluid, and we want to consider the turbulence with a Reynolds averaged numerical simulation. Then we click on OK and close this. The next step is to define the fluid. Here are some predefined fluids, for example, air. As a fluid, we take water. Then we click on OK, and this is defined. For the simulation, you need some initial values. Initial values are given here. You click on it, and if possible, you should say that it is a potential flow. Sometimes it does not work, so you have to define initial values. But in this case, you can say it is a potential flow, and you can define it. The turbulence has also some initial values, and you click on OK and close it. Now your simulation properties are through, and then you can, before starting the simulation, you should save the model, go to File, say you want to save it, and then go here, Save, and then you can go to the solver. You click here, or you can, for the solver, you can click also here, make a double click on it, and the solver itself is OpenFOAM. The communication runs via ASCII files, so you have to write these ASCII files. You click on Write, If you want to review the ASCII files, you can click on Edit. So you can take a look on the ASCII files, for example, on the control dict files. In the control dict file, you see that the application will be simple foam. You can see other simulation properties. If necessary, you can edit them. In this case, it's not necessary to edit the control dict file, so we close it. Now it's time to start the solver. The solver, in this case, it's a very simple model. The solver will run about 40 or 50 seconds. So see you later in 50 seconds. Now the simulation has finished. During simulation, CFD-OF shows this chart, which gives you an information about the residuals. Residual is a comparison between the values from one step to another step. It is given as overall knots, overall simulation points. And the simulation will stop if all residuals are below this threshold, below 10 power minus 4. Another way to stop the simulation if the maximum number of iteration is achieved. The simulation has finished. To review the simulation, we go to Paraview. You click on Paraview. This is a post-processor for the simulation. And here occurs the model. The model occurs also in different time steps. We can go to the velocity. So this is the first time step up after 100 iterations. You can go to the last step. And this is a velocity in the sim model. As a boundary condition, we entered 10 meter per second. So this is the boundary conditions. And you see that the velocity changes. You can take also a look on the flow using glyphs. Okay. The glyph is started with this button. Then here you see the review for the glyphs. I recommend to reduce the maximum number of sample points to, for example, to 1,000. If you click on apply, you see the errors. So these errors give you an idea how the flow runs. You can also click on this eye in order to see only the arrows. Another way to review your simulation is a stream tracer. So first you have to remove the glyphs and go to the stream tracer. Click on it, and then you see here some parameters for the stream tracer. And here you have the starting point of the iteration. So you can click on it and move it. Here you see the green point. You can move it. So we want to review the stream tracer in this over this line. Here is given the line parameters. We say that on x coordinate we want to have 0.1. The y coordinates are okay, and we want to take a look on the midplane. It is recommended to reduce the resolution. The standard value is 1,000 points. You can reduce this to 100 points. If you say apply, you see here the the flow given as a line. So here you see the flow coming in, and here you see some kind of turbulence or vortice. And yes, so you see that here the flow is running in like a circle. So you see that Paraview has a lot of opportunities. In further tutorials, I will show you other possibilities to review your simulation. So now the first part is through. Thank you very much for your attention and hope to see you in the second lesson. Bye bye.